How is it that we've been able to build computers using the quantum world? We are building at an ever-increasing rate more and more sophisticated quantum computers. These are the hardware that will give us the compute, the power to really drive AI into the next level. AI is effectively the software. Put these together and you can harness almost unlimited power. Sometimes if you're watching something about quantum computers, you might, like me, find, I don't know what I'm looking at. The goal here is to make this more accessible. Let's start with this. In the 1940s, the world's first working transistor was created, the basis of the modern computer. In effect, this is just an electrical switch, on or off, which we have designated 0 and 1. These transistors are made out of semiconductors because they can semi-conduct. The switch can be on or off. In essence, we can use the transistor to make electricity smart by storing information. Now with this 0 and 1, this combination, with lots of them, we can use it to create codes. So the letter A, for example, has this code. The 1 and the 0 is just a single bit of information. With even more bits, we can create logic gates and circuits to give instructions to the computer to make decisions, all just based on storing this data in huge numbers of ones and zeros. And ultimately, CPUs, which is a set of instructions created by ones and zeros, which can control the whole system. We've organised the electricity in a way in which the computer can understand information and even make calculations. Now with the modern day computer, we have billions of transistors in your iPhone, which is why it's able to do all of the things it can. Now to take that into the quantum world, things become a bit more absurd. Part of the problem is we don't fully understand quantum mechanics. As Richard Feynman said, nobody understands quantum mechanics. Most quantum computers might have 10 or even 100 qubits in it. These are real atoms in a vacuum chamber held inside the quantum computer. The difference is that it's not a transistor. The qubit can be an ion or an electron or a photon. It's just something that we can use to create code. With an electron, it is the electron's spin that we create the binary choice from, up or down. That creates the 0 or the 1. All we're doing is engineering those atoms so that they can have a binary code, so we can use it to code things in to the computer. The difference is superposition. To us, the world looks like it's solid all the way through, but it doesn't work like that at the quantum level. Quantum level, we have something called superposition, which means that particles are effectively in all positions they could be in until the point that they're measured. They're in all of them at once, and it's probabilistic. An electron could be 70% chance of being up, or 30% down, or any combination of those numbers. Until it's measured, in other words, until we look at it, it doesn't fix into a definitive position. Now, why is it that looking at it, us looking at it, causes it to collapse into a single position? We have no idea. There's lots of theories why that is, but we don't know. But we have proven it time after time with the double slit experiment. A single particle is almost like a box full of particles of options. That's why some people call it a wave. And then when it collapses, it's a single particle. That creates all sorts of theories like parallel universes, and there is one electron in the whole universe. That is every electron. There's lots of theories. Once superposition has created many variables within the qubits, quantum entanglement then pulls them all together or ties them all together. This is another concept within quantum mechanics that makes absolutely no sense. But the superposition is what gives a quantum computer its power. Because unlike a transistor, where one transistor gives you one binary choice of 0 and 1, with a quantum or a qubit, you effectively have a superposition of 1 and 0. That creates so many combinations that by the time you have 300 qubits, you have more potential combinations than all of the atoms in the universe. Therefore, you can code immense information into a quantum computer, and therefore you have huge amounts of power. Whereas in a classical computer, you'd need to have more and more transistors You don't need to do that with a quantum computer. With more modern quantum computers, you have quantum chips, which are cryogenically frozen, super cool chips, which contain circuits with qubits in them. Most recently, we had the breakthrough of Google's Willow chip.
Introducing our latest quantum computing chip, developed to learn and evolve like the natural world around us. Willow, from Google Quantum AI.
And the amazing thing about this is that for most quantum computers, as they scale up and you add more qubits, the more likely they are to fall out of superposition. If the qubits fall out of superposition, the system stops working, and it's harder to keep more and more qubits in superposition. The Willow chip has managed to scale up the number of qubits whilst decreasing its decoherence rate, the error rate, i.e. decreasing the number of qubits that fall out of superposition. So massive waves are being made in the quantum computing world. If I just give you a thought experiment for a minute, a lot of this is happening beyond people's realizations. Most people don't really know what's going on at the frontiers of technology, but it is absolutely insane. Now take where we are now and add 100 years. What does that even look like at the rate of change we are creating at the moment? We now have quantum computers completing mathematical tasks that would take classical supercomputers millions of years or billions of years. That's because of the number of combinations they can go through at once.
Our quantum computer completed a benchmark computation in 200 seconds that would have taken the world's fastest supercomputer at the time 10,000 years.
It grew from 10,000 years in 2019 to 10 to the power of 25 years, or in words, 10 septillion years on the Willow chip. This illustrates the double exponential growth in compute power.
The reason that quantum computers will become important for AI is we have a problem with a scaling wall. The more compute we give AI, we have seemingly diminishing returns on its efficiency and its speed. So we're now building these massive Titan data centers to try and account for that. But the scaling wall persists. What we need is truly enormous power. With classical AI as well, we have data centers run on GPUs. That cost problem of energy and the cost of building them limits the ability to build up power. All of that is removed with quantum computers. The goal, therefore, is that it can be used to massively reduce the energy cost currently needed for AI. Quantum computers, therefore, have the potential to create truly unlimited power to power the AI brains. But quantum computers won't just provide more power for AI, they will fundamentally change the algorithms on which AI is based. Quantum computers can use quantum algorithms to find potential outcomes faster and go through all potential outcomes. Quantum neural nets won't just be faster, however, they will fundamentally change the architecture of an AI model in ways that are unavailable to neural nets of a classical computer, using things like entanglement to capture correlations in the world, correlations that a classical computer might take years to find. The immense reasoning computational power could then be used to decode certain viruses. It could be used to cure certain cancers, for example. There are also synergies where the AI can help make the quantum system more stable, so we can scale them much further. The problem is it's hard to reliably manipulate qubits because of decoherence. We're likely to have a hybrid in the near future of using quantum computers, or QPUs, and GPUs at the same time. But if we learn to fully control the quantum computers, there is no end to the level of scaling that we could do, and therefore there is no end to the intelligence that we can produce. There's no problem that we couldn't solve. There is no medicine that we couldn't figure out, no cure that we couldn't have. We will have created a god. If you like this channel, please do subscribe. Thank you.